Performing FTIR spectroscopy in a glovebox. Gloveboxes are used in many fields of scientific research that involve chemical substances that are sensitive to moisture and/or air. This could be in the development of catalysts, clean energy research, or fundamental chemistry, among others. Conducting FTIR experiments under inert conditions outside a glovebox, though possible, is quite tedious. Users must consider many parameters. For example, the transport from glovebox to instrument, or, since ATR is not applicable due to its open design, the sample preparation for transmission measurements in a sealed IR cell. Fortunately, our compact benchtop FTIR spectrometer Alpha 2 can move between the fume hood and the glovebox on demand. For this video, we are going to introduce the Alpha 2 into this nitrogen gas-filled glovebox to measure sensitive organometallic compounds. We already equipped a platinum ATR module and prepare the Alpha for the airlock by opening the backplate for pressure compensation. To make things even easier, we also attach a Wi-Fi module to avoid any extra cables. When we are finished, we can close the airlock and start evacuating. This might take a few minutes. Afterwards, we can flood the airlock with nitrogen gas. Now we are ready to start setting up the Alpha. We take it out of the airlock and switch it on. Now we can take a look at the computer and its software. The green status lamp in the lower left indicates that the Alpha 2 has already connected to Opus Touch wirelessly. With this we are all set, start the analysis workflow and begin by collecting a background before returning to the glovebox. These are the metal organic samples that we will analyze. They are provided to us by the courtesy of the workgroup of Professor Dr. Schirin Hanf from the Karlsruhe Institute of Technology. We place the powder on the ATR and apply pressure. The preview spectrum looks promising, and we click on Start Sample Measurement. After a few seconds, the measured spectrum opens automatically, and we start interpreting the IR data by moving it to the spectra display. We can integrate, pick peaks, or start an identification or quantification method if applicable. We save our edits to the spectrum, go back to the workflow, and click on Next Sample to continue. Within a few minutes, the Alpha 2 has gone through all the samples and is ready to be taken back to the fume hood. After ejecting, we take the instrument and place it back into the lab for the next task. Or a classroom for the next lesson. Or why not the professor's office? Thanks again to the Karlsruhe Institute of Technology and Junior Professor Dr. Schirin Hanf for supporting us in the creation of this video. See you next time!